So if you have to solve a system of equations, you can use something called Cramer's rule or Cramer's method. I can never remember which one it is, rule or method. But either way, Cramer gives us this. First, put everything in put all the coefficients into a matrix and just call it A. That's the coefficient matrix A. So to find out each variable solution, we need an x, we need a y, we need a z. The x is found by taking this determinant, and then you divide it by the determinant of A. Okay, so that means we got to go off and calculate the determinant of A. So let's go do that over here. So I always teach my students finding the determinant with a submatrix. And the way you do that is you take, you could go by rows or by columns, but if you go across the row, starting with 1, you make a submatrix of everything that's not in its row and in its column. And that's 1, 1, 2, and 1. So we need to take the determinant of that submatrix. Oops. And then we subtract from that the determinant by using 2 in its submatrix. So here's the number 2. And its submatrix is everything that's not in these rows and columns with the 2. So that's a 2, 1, 1, 1. Then you add the third submatrix that's formed. So -1, its submatrix is going to be 2, 1, 1, 2. Okay, so now to finish calculating the determinant. Determinant of this matrix, you multiply the top left diagonal, so that's 1, and subtracted by the other diagonal, 2. 1 subtracted by 2 is -1. -1 times 1 gives us -1. 2 subtracted by 1 gives us 2. 2 subtracted by 1 gives us 1. 1 times 2 gives us -2. Then we got 4 subtracted by 1 gives us 3. And 3 times -1 gives us -3. So the determinant we just found out is -6. So, back up here we know what we need. This is supposed to be -6. So now we just need the blue determinant. Again, that's a 3 by 3, so use that. If you use that submatrix idea, that determinant's going to be 4 times 1, 1, 1, 1, 1, 2, 1. Okay, again, I'm getting these numbers because here's 4, and here's its submatrix, all these guys. 1, 1, 2, 1. 1, 1, 2, 1. So there's 4, then you're supposed to subtract it by the second submatrix. 2 submatrix, -2, 1, 2, 1. Then you're going to add the final submatrix, which is made by -1, submatrix, -2, 1, 1, 2, -2, 1, 1, 2. So to finish calculating that determinant, this is going to be 1 subtracted by 2 gives us -1, and -1 times 4 gives us -4. Now on to the next matrix. So we have -2 times 1 is -2, 2 times 1 is 2, so -2 subtracted by 2 gives us -4, -4 times -2 gives us +8. Oops, and I spotted a boo-boo here when I copied the submatrix. This is a 2 here, okay? Right here, it's supposed to be a 2. Because the submatrix, here's -1. The submatrix is supposed to be -2, 1, 2, 2. So, got that caught. So we got -2 times 2 is -4. -4 subtracted by 2 is -6. -6 times -1 gives us a +6. So you add those guys up, and you get 10. So 10 over -6. And so that simplifies to be -5 over 3 if you'd like. That's our x. Okay, so that's what we said over here. This is how you find your x. Yeah, so to find the y, I kind of skipped over this, I think. To find the y, the formula goes, take your matrix again, your A matrix, which is 1, you can see what I'm looking at here. A matrix is 1, 2, 1. I'm going to skip over the y column because, this is supposed to be determinant, okay? Determinant. We're taking the determinant of this. And in the y column, I'm going to put these answers over here, what it all equals, the constants, the 4, the -2, and the 2. Just like I did over here. I replaced the x column with 4, -2, and 2. So 4, -2, and 2 goes into the y column. So I got 4, -2, and 2. Determinant of that over determinant of A again. So you should see a pattern. To find your x, you put those constants that come at the end in the x column, divided by the determinant of A. To find the y, you put those constants in the y column, take the determinant, divide by A, just like we did up above. So So up top is the determinant of this matrix right here in black, the top one, all being divided by the determinant of A, which is negative 6. So if we simplify that guy, this determinant, negative 2 subtracted by 2 is negative 4. Negative 4 times 1 is negative 4. This determinant, 2 subtracted by 1 is 1. 1 times negative 4 gives us a negative 4. And then 4 subtracted by negative 2 gives us 6. 6 times negative 1 gives us positive 6. Okay, and it's all being divided by determinant of A, which is negative 6. So y is negative 1. Just like that, we got our x, we got our y. Even though we had fractions, I mean, if you've done solving with elimination with 3 variables, you know fractions are a huge pain to deal with. So this bypasses that. We don't even need to use fractions anymore to get y. Now to get z, I bet you can guess what's going to happen. Z is found by taking the determinant of the coefficient matrix except 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, except the z column is going to be replaced with the coefficient, the constants over here. 4, negative 2, 2, 4, negative 2, 2. It's all being divided by determinant of A, which is negative 6. So you saw me crunch a couple of determinants up there, so let me crunch this real quick, the top one, what this should be. Here's what it looks like, and when you do each one, that's what you should get when you crunch those numbers. So you get 1 for z. So we got z equals 1. What do we have for y? Where'd it go? Y is negative 1. And then x we had to be something ugly. I think it was negative 10 over 6, which is negative 5 over 3. You punch those bad boys into the original system, and you should get a true statement of each equation. Okay? So there, when you have fractions, Cramer's rule is the way to go.